equations.
A little bit.
What I'm looking at here to do today is over the course of the next 2 weeks, we're going to be basically working with systems of equations. We're going to be working with systems of equations that are linear. We'll be working with systems of equations in inequalities. We'll be looking at systems of equations that will have a little bit of absolute value thrown into them. We'll look at systems of equations that will eventually create what are called constraint, bless you, that'll create, bless you, wait for the third one, no. We're going to create what are called constraint problems. It's called linear programming. So eventually, by the end of next week, we will be almost done with chapter 3. It doesn't take that long to go through a lot of this. But one of the first things I want you to remind you of is when you're solving systems of equations is how do you set it up, and do you remember the different methods to do so? If you recall, there's a couple of them. You have what's called elimination, you have substitution, and then you have linear combination. Remember those three? Now, elimination or substitution or linear combination, it totally depends on the style of problem as to which one you want to use. For example, if I'm looking at this one, 3x plus 4y is negative 4, x plus 2y is 2, there's a couple of things that I could do quickly to solve it. One of which is that I could double the bottom equation and subtract it from the first. That is a linear combination method. Another way I could do that one is I could get x by itself from that bottom equation and substitute if I wanted to. Either way, it doesn't matter. I should still get the same result. Personally, when I see 2s and 4s and things like that, I just double the bottom one and rewrite because I think it's quicker. Okay? So, for example, if I take this, I'm going to rewrite the top one, and I'm going to double the bottom one. And I get that. Exactly. And there's a little trick that I do that's different than what you might see in a textbook or from what other people do. If I'm going to take that top equation and subtract the bottom one, I kind of oversimplify it. I draw in this, and then I put 3 subtraction symbols. The reason that I do that is so that way I don't forget that I'm subtracting each individual part. It forces me to distribute that negative throughout all parts of the bottom equation. Time and time again, I see people that will forget to do that to the last term or the middle one, or just forget a sign here or there. By doing it this way, it forces you to go, oh, what's 3 minus 2? 4 minus 4, nothing. And negative 4 minus 4 is, so x is negative 8.
And then you substitute it in.
And I go right back. Okay? That's one of the quick methods of doing things. If I did substitution, I should still get the same result. The 15 clicks to get there, right? Isn't it awful?
Yeah.
I know.
Why should you double the bottom one and not the top one?
If I doubled the top one, I'd have 6x, 8y, and a negative 8, and that would have been, what I'm trying to do is eliminate one of the variables. By doubling the bottom one, I can eliminate the y's. I could have multiplied the bottom one by 3 and eliminate the x. There's a whole bunch of different scenarios you can set it up. This, to me, I just see even numbers and I just think doubling real quick. Okay.
Or
So-
you could divide the top one by 2, but that would be messy.
Yeah, you're right. That's the whole idea. There are so many different ways of doing it. It's just a matter of picking it and going. Do you want me to go back and substitute the negative 8? I might as well. I'm doing that. If I substitute back in here, I get negative 8. I got negative 8. A 2y is 2, which means 2y is 10, which means our answer is 5. And when you have system of equations, what you're looking for is where the 2 lines are intersecting. So your answers will always be written as ordered pairs. Okay? That's one of the ways of doing it. Same thing on the other one. Oh, I'm not going to bother. Let me find a trickier one. Oh, were you still writing that down? I'm sorry. Were you okay? Hey, how'd you do yesterday? Did you beat the Rooski?
It was, I like slept through the
Oh.
no.
She
You
was
okay?
doing really good though.
You okay?
Yeah, so went to the doctor and they don't know what happened, but yeah.
She drugged you. She is Russian. They are known for drugging.
No, I saw her last night. I was at the soccer game after I saw her, and she got fourth because she took a wrong turn. Yeah, we all
She does it all the time.
That's
She's
so
like,
awesome.
She's like at state, and she's like, yeah, I was running around, I couldn't figure out like where the
But she like stands away.
That, you know what? I just think that's funny. Christina's great. I just think it's funny. How'd you do yesterday?
Me?
Yeah.
No, I should really bad.
Nice.
We still won though. Rochelle's horrible.
If I look at one like this, it's not as easy to decide which one you want to do. I mean, you can do multiple methods. So if we have 2x minus 4y is 13, 4x minus 5y is 8.
Let's double it.
Double which one? The top one?
Bottom one.
If I double the bottom one, is that good? It's not going to get me anywhere, is it? Because what we want to do here, here's the trick. You want to create this. You want the same coefficient with the same sign. You would subtract. Or you want same coefficient with opposite sign, and then you would add. These are the two different things you're trying to do. I don't think there's two f's in the coefficient, so. It is kind of weird. So those are your two options that you're trying to create. You're trying to create the same sign, or excuse me, the same coefficient, either have same or opposite signs. To be honest with you, if you ever have opposite signs, try to get those coefficients to become the same because you guys are less likely to screw up if you're adding than you are subtracting. But in this case, we have all the same signs, so it's a little bit tough. So what I would do here is just double the top one. Now, when I'm writing down these problems, before I even write down the problem, I'm going to start there and think, hey, a knucklehead, I'm just going to double the top one. So as I do that, I'm just going to write the answer, like double it, and write it below here as I'm writing it down. And then I split it, and I subtract. Because you have the same coefficient, same signs, you have to subtract, so the x's are gone. We have a 3y, and what is that? Negative something, it was an 18?
Yeah.
Negative 18. So it gives us a y value of a negative 6. And then you just substitute back and get your x value. I know that you got, yes sir?
I did that and I got X is
Okay, let's see what we do. So we substitute back up. Let's see here, we got 4x. Negative 5 times negative 6 is a 30, is an 8. Bless you. Bless you. Even if you do the top one or the bottom one, you should still get the exact same result. So when you divide this by 4, you get x equals a negative 11 over 2, which is negative 5.5. Leave it as the improper fraction, okay? Hey, Chris?
How do you know whether it's double or top and bottom?
It's totally different. Every problem is independent. You could have done many different things. I could have taken this top equation, multiplied it by 5, the bottom equation, multiplied it by 4, and got 20s in the middle here, eliminated that, and gone this route. I could have taken this one and cut it in half and dealt with fractions. There are so many different things you can do. It's totally up to you. My suggestion is that you look for the easiest one. Look for even numbers. Look for ones that you can just double or multiply by 3, something like that. Sometimes you have to multiply top and bottom to get like a GCF, if you will, or an LCM. That's what these kind of multiple, things like that. Each problem is a little bit different. Okay. Ms. Myers, what do you got? Congratulations. Do you guys remember what happens if you get, we're running out of time, so I don't want to get into this problem here. What happens if you get this? What happens if you go through the whole system of equations and your answer is 4 equals 4?
Yeah.
You're right. Yes, you're right. What's the answer?
All answers.
All answers. What this means, if you get a true statement, and it was kind of a dumb luck that you said it like that. What happens if you get a true statement when you're done? You get like 6 equals 6, -3 equals -3, and you didn't screw up. This just means all real numbers, all solutions. If you get something that is then the answer is no.
No, I was being
No
serious.
solution.
I was being serious when I said yes.
I kind of figured that. That's why I was kind of laughing. Remember what that means, no solution? That just means that nothing's going to work. Okay? Let me give you guys, I don't know, maybe 6 or 7 of these maybe? That should be enough, right?
Something that I remember showing, was this in Algebra 1 or Geometry, when it had like those like squiggly like bracket things and it was like domain?
We still do a little bit of domain and range, but not as much. We'll talk a little bit more about domain range as we get into this more complex
They're
Stuff.
like in the last 2 classes I've taken. That's like the one thing that I like never really knew what I was doing.
I hate that there's so many clicks they have to get here. So this is chapter 3. I think this is 3.2. I forget what problem it is. Yeah. Let's do this. Let's do. So this is section 3.2. So it's 3.2. It's on page 147 of the book. Let's do 44 to 49 and 54 for right now. Yeah. Okay with that? 44 through 49 and 54.